Continuation for MYE Chemistry, paper 24-25. Question number 20. An ionic compound is formed from force of attraction between a positive and negative ions. An iron 3 ion has a formula of Fe3, and a sulfite ion has a formula of SO3 2 negative. What is the formula for iron 3 sulfite? So as the given shows that our iron 3 has a charge of 3 positive, and sulfite ion, which is SO3, has a charge of 2 negative. To form their compound or their formula, simply just exchange the number or cross the number. So we will have Fe2 SO3 3. We need 2 Fe3 plus to matches the SO3 ions, and we need 3 SO3 ions to matches the iron compound. So this will be the formula of our iron 3 sulfite. So that's why the answer is letter C. Next, number 21. Selenium is in group 6 of the periodic table. What will be the charge of selenium ion? Remember, the charge can be based on their group number. So group 6 means they have 6 electrons in the outer shell. Therefore, it will require to receive 2 more electrons to complete the valence electron. Therefore, if they will add 2 more electrons in their outer shell, they will become 2 negative. So that is their charge. So the one that has 2 positive charge are the group 2, because they are the one who will be expected to lose 2 electrons. The one that has positive 3 charge are the group 3. They will lose 3 electrons. And the one that has a charge of negative 3 are group 5, because they are the one that we are expect to receive 3 electrons to have 8 electrons in the outer shell. Question number 22. Naturally occurring bromine has a relative atomic mass of 80 and consists of entirely 2 isotopes of relative atomic masses 79 and 81. What is the ratio of abundance between bromine 79 and bromine 81? Remember the formula for relative atomic masses. You need to multiply. So the relative atomic mass is equal to the mass of the first isotopes multiplied by the abundance of that isotopes added to the mass of the second isotope and the relative abundance of that second isotopes, and so on and so forth, divided by 100. So you can also assume that there are 100 atoms, just like in this case. If there are 100 atoms of bromine, how much of it is bromine 79 and how much is bromine 81? So if you're going to use the algebra, you can just assume that the first isotopes abundance of the first isotopes is x, and the second one will be 100 minus x. Now, another shorter way of doing this, if you're going to look at it, 79 multiplied by the abundance plus 81 multiplied by another abundance divided by 100, the answer should be 80. So you can see here that 79 and 81, if you add them divide by 2, you will get the average of 80. So it means that the abundance between them is 50-50, or we have a 1:1 abundance. Now you can analyze it if you're going to look at other examples. If the relative atomic mass is closer to one of the isotopes, so it means that isotopes has more abundance than the other. So for example, if it's 79 point something, or if it's 81 points, 80 point something. Okay. Question 23. Which statement about the isotopes of chlorine is correct? Remember the definition of isotopes. Isotopes are elements with the same number of protons, because we're talking about the same elements, which has different number of neutrons. So if the number of neutrons are changing, it means their mass number is also changing. So from our statement, we can cancel already statement letter B and statement letter D, because it's talking about the same number of neutrons. What is correct is they have the same number of protons. Now, isotopes have same number of protons and electrons, therefore their chemical properties will be the same. Chemical properties are usually dependent on their chemical bonding, or in their number of electrons. Now, the physical properties can be dependent on the number of mass, or the mass number rather. So it means in our statement here, we are expecting that the isotopes should have the same chemical properties, okay, but not physical properties. So the correct answer is A. Sorry, the correct answer is C. Question number 24. Which statement about the structure or bonding of metals is correct? Metals have high melting point. That is correct, because of the strong attraction between metal ions. So remember, the attraction is between positive ions and electrons, or the sea of electrons. Letter B. Metals are ductile, as metal ions slide over one another. So they are ductile, so that's correct. Letter C. Metals are malleable, also correct, because of the ions present in are mobile. So this is not the reason. Okay. So these ions that are mobile, this is the reason why they are good conductor. Letter D. The ions in a metal move when they are connected to the positive and negative terminal of the battery. So it's not only when they are connected. So remember, the conductivity of the metal is not because of its ion, but because of its sea of electrons, or the localized electrons. So the correct answer is B. Number 25, which diagram shows an incorrect dot and cross diagram of a covalent compound? So let's see first the formula based on the bonding. So we have P, which is our phosphorus, which is in group 5. So you can count 1, 2, 3, 4, 5 X's there, so that's correct. And then we have 3Cl, so the name here is potassium tetrachloride. Chlorine is in group 7, so there should be 7 dots. 1, 2, 3, 4, 5, 6, 7. So all of them has 7 dots. So the valence electrons are correct. But then after the bonding, after the sharing, you will see that they will all complete 8 electrons in the outer shell. So this is correct. Letter B is 2 hydrogen and 1 oxygen, so that is H2O. So as we all know, hydrogen has 1 electron only, so this one is wrong. We should not have that. And then oxygen has 6, so that's 1, 2, 3, 4, 5, 6. That's correct. Then this is the one, the sharing is the best. So this excess electron is what made it wrong. Letter C is CH4, or also known as methane. So you can see here how each hydrogen has 1 dot only, while our carbon has 4x. And then sharing makes them make them has their full valence electron. So that is also correct. Then letter D is our N2. Nitrogen has 5, so 1, 2, 3, 4, 5. Another nitrogen has 1, 2, 3, 4, 5. And then to complete the 8, they need to share 3 each, so that's why they form 3 bonds. So this is also a correct diagram. So the answer is letter B.